All right, guys, so this is going to be number 5 from Suggested Problems, Activity 13.1 and 13.2. It actually says graph negative f of 2x plus 4 minus 3. On number 4 in the previous video, it was an actual equation that you could plug into a calculator and actually just trace the graph. You can't do you cannot do that strategy here. You actually have to know how to do this by hand. All right. So the first thing I see is I actually give you the parent function 1 over x in the problem. From that parent function, you're going to generate quite a few important points. And at this point, you should recognize that we're going to be using a t-chart. All right, so I've got my t-chart filled out now down on the bottom here. These are all of my points I want to use. If you notice the difference between this video and last video, I actually added 2 more additional points. Only takes a couple more seconds to calculate it. It actually gives me an idea on where it's actually the actual shape's going. All right, now we got to mess with this part over here. This is not in the form that we're used to seeing. The form we're used to seeing is AF of B times X minus C plus D. So very much like number 4, I'm actually going to have to manipulate the inside of the parentheses here to make it look like this part here. So the way I do that is I just factor out a 2, and this makes my equation negative f of 2 times x plus 2, don't forget you have to take the 2 out of the 4 as well, minus 3. Now, this inner part here is going to affect your x's and it's going to be opposite. And of course, we got to do PEMDAS. So inside we're multiplying. So we're going to have to multiply by the opposite. So I'm going to add this to my t-chart here. So I'm going to do 1/2 x. And instead of plus 2, we're going to do minus 2. Now we're taking all of these values and I'm plugging it back here. Okay, and then everything on the outside, like the negative here, and my minus 3, that's at face value. Those are going to affect my y values. So I'm going to create an equation for that. Negative y minus 3. And I'm going to take all of these y values and plug them into here. All right, so I went ahead and did all the math here. So all of these points, I just inputted into this and got these values. All of these y values, I inputted right here to the y and got all of these new y values. This will give me, let's see, a point at negative 3, negative 2.5, negative 2.5, negative 2, negative 2.25, and negative 1. We are going to have an asymptote at negative 2. So when x equals negative 2, we're going to have an asymptote when y equals negative 3, because that's where my errors are. I'm going to have another point at negative 1.75 and negative 5, negative 1.5 and 4, negative 1 and negative 3.5. All right, guys, sorry about that. This 1 here, this should actually be a negative 4. I don't know what I was thinking. I just didn't copy down my negative. Now I have all that information. We're just going to go ahead and graph it. Drawing an XY axis, good enough. Here's my x, there's my y. Let's draw in my asymptotes. I have x equals negative 2. X equals negative 2. I have y equals negative 3. Y equals negative 3. And then let's just start plotting points. We have negative 3, negative 2.5. That's up here. We have negative 2.5 and negative 2. That's here. we have negative 2.25 and negative 1, that's there. Negative 1.75 and negative 5, that's down here. We have a negative 1.5 and a negative 4, and of course then a negative 1 and a negative 3.5. So my graph is doing something like this. And then we are all done. That is your graph. It's the exact same procedure as number 5. The only difference is one has an equation you can put in a calculator. The other one has an equation you cannot put in the calculator.